Good afternoon. My name is Victor Leung. I'm a professor emeritus with the University of British Columbia in Canada and a distinguished professor with Shenzhen University in China. It is a great honor to be invited to give this opening keynote presentation to the 2020 Summer School for Autonomous and Intelligent Unmanned Vehicles, sponsored by the IEEE Census Council and organized by Sejong University in Korea. Due to the global pandemic, I regret that I'm unable to meet you personally at the summer school. Instead, this presentation has been previously recorded and delivered to you over the internet. Now let me share my screen with you. The title of my presentation is Towards Intelligent Unmanned Vehicles. I shall focus on unmanned aerial vehicles or drones and briefly introduce their evolution towards autonomous intelligent drones, which is motivating intense research activities on integrating artificial intelligence and Internet of Things technologies to make intelligent drones a reality. I shall close the presentation by highlighting some research areas that graduate students can focus on in their studies on autonomous and intelligent unmanned aerial vehicles. Unmanned aerial vehicles are commonly known as drones. These are aircraft or flying machines without a human pilot on board. Drones have been around for a long time, initially used by the military for surveillance or combat purposes. More recently, with the advent of affordable technologies, drones have begun to find widespread civilian applications in commercial, industrial, agricultural, or recreation settings. While many military drones look like miniature aircraft with fixed wings, the civilian drones mostly look like miniature helicopters with multiple rotors. The one with 4 sets of rotors, as shown on the left side of this slide, popularized by the Chinese company Dajiang Innovations, is called the quadcopter. Typically, a drone is equipped with a radio for communications with the remote human operator and an onboard computerized controller to receive the remote commands and execute them as flight control. Many drones are also equipped with video cameras as well as GPS receivers. A civilian drone typically communicates with the remote human-operated control terminal via a Wi-Fi link, which might also be used to transmit video images back to the remote terminal to provide visual feedback to the remote pilot. Civilian drones are typically dumb machines without any built-in intelligence, which responds only to the directions of the remote pilot. However, advanced high-end civilian drones are emerging with increasing levels of intelligence. For example, many high-end drones would memorize the flight paths so that they could autonomously return to the locations where they were launched should radio contact be lost. Unmanned aerial vehicles are not the only types of unmanned vehicles. In fact, unmanned vehicles can be confined to the ground, such as on streets or highways, as in autonomous vehicles that are emerging around the world. Unmanned maritime vehicles are another type of unmanned vehicles that are used in maritime or aquatic environments, either on the surface of a body of water or underwater. Unmanned vehicles can also be classified as remotely operated by commands sent over wireless communication links or autonomously operated using built-in mission instructions, location determining capabilities, and sensors. While remotely operated drones are fun to fly, they are also prone to human errors, whether these errors are intentional or accidental, which may have great negative impacts on the community. For example, in 2019, London Gatwick Airport was shut down several times due to the intrusion of drones into its airspace. And there were also many instances of drones crashing into various structures, such as the Milan Cathedral and the lawn of the White House. Around the world, governments are putting regulations into place requiring training and licensing for drone operators and restricting the space over which drones can operate. It is anticipated that some degrees of autonomous capabilities will be built into drones to satisfy government regulations and overcome operator errors. In the meantime, drones that are totally autonomous in their operations are also emerging. To make these possible, lots of research and developments will be needed. At the present time, there are many research opportunities and potential for innovations awaiting exploitation by smart graduate students like yourself. In order for an autonomous unmanned vehicles to carry out increasingly sophisticated missions without human intervention, such as flying in a swarm formation, it needs to make use of its sensor data intelligently for context and situation awareness. There are intense research and development efforts around the world to incorporate advanced machine learning and artificial intelligence-based decision capabilities into autonomous unmanned vehicles. This slide shows some of the innovative research projects on autonomous drones around the world. In the United States, Massachusetts Institute of Technology is developing a quadcopter that employs a camera with artificial intelligence to avoid objects. In Canada, University of Sherbrooke is developing a fixed-wing drone that supports various landing options. In the Netherlands, Delft University of Technology is developing a vertical landing and takeoff aircopter capable of long-range autonomous flight. And in Switzerland, the Dalmolly Institute is developing autonomous drones that utilize deep neural networks to enable them to follow forest trails. This slide shows that the global market for drones is quite sizable. From a market size of about $14 billion in 2018, the market is forecasted to grow at an annual rate of 20.5% to about $43 billion in 2024. Due to government regulations as mentioned above, in order that drones can be operated safely for a variety of applications, it will be crucial to incorporate artificial intelligence into drone designs if the market potential projected in this slide is to be realized. In this slide, we look at the anatomy of an intelligent drone, the key underlying technologies, and the important research challenges in the roads ahead. As shown on the upper half of the graph of the slides, an intelligent drone is composed of energy storage and propulsion systems and an AI-based drone platform incorporating the navigation and flight control systems, as well as other mission-critical functions, sensor systems, and communication system. The AI-based drone platform is the brain of the drone, with powerful computation capability driven by software that also supports artificial intelligence. The sensor system may include cameras, lidars, altimeters, speed sensors, GPS receiver, and so on, which provide the data that are utilized by the AI engine for situation and context awareness, navigation control, and other mission-related functions. Now let us consider some of the research challenges, which are divided into 4 areas as shown in the lower half of the slide. The AI-based drone platform is resource limited, but at the same time, mission critical. So how to make the software robust while integrating AI capabilities into a small footprint will be a very challenging proposition. Detection and control are key functions that utilize sensor data and AI capabilities to enable mission-critical tasks in real time. Now, doing a lot of computations while subject to strict time constraint is always challenging, and a lot of research will be needed in this direction. Communications and security. The drone needs to perform mission-critical communications should it need to send mission-related data back to the ground or collaborate with other drones. Wireless communications are by nature prone to interception and interference. Therefore, securing mission-critical communications is a big challenge. In addition to strong encryption, novel, robust communication techniques and architectures that provide protection against interference needs to be explored. Autonomous intelligence. This is the research to develop the brain of the AI-based drone, focusing on AI algorithms for decisions, optimization of learning to distill knowledge, distributed learning, and so on. There is a lot of current interest in AI-enabled Internet of Things based on lightweight implementation of machine learning for embedded processes, so-called tiny ML, which is very relevant to AI-based drones. However, there also needs to be further investigation into large-scale scenarios or complicated missions in which collaboration between drones or between layers of computing nodes need to be leveraged to scale up the AI capability. To summarize, the design of drones are evolving so that they are becoming a faster, smaller, cheaper, and smarter machines based on the advancing core technology mentioned in the previous slide. We expect that artificial intelligence will be widely deployed in autonomous intelligent drones in the very near future. To get there are many interesting and important research opportunities that should capture the attention of many graduate students and researchers like yourself. That is all I have for you. I think you will find more details about intelligent drones in the subsequent sessions of this meeting. Enjoy the rest of the summer school and keep healthy and safe. Thank you very much. 감사합니다.